Howdy team, welcome to this video 3 about looping. And in this video, we're going to talk about for loops. So for loops are definite loops. As we just talked about, that means that we know how many times a for loop should execute. We're able to give it a concrete number of times. So let's talk about how that works. So far in the code that we've seen before, whenever we want to repeat a statement, it's pretty redundant. We say system.out.print something, and then I'm going to say howdy and howdy and howdy and howdy and howdy. And if I'm going to do that many times, we have to print it out that many times. And what if instead of howdy, I suddenly started saying sup or something? That's my husband's thing, sup. So if instead of sup, I would have to replace it in 5 different places. And that can lead to bugs. Right now, all these 5 places are right next to each other, but it is possible that they would get separated at some point. And it's possible that we would leave some howdy somewhere. It is better to have something written one time and have the computer repeat it than have us have it multiple times, because that gives way to error. We don't want that. So Java's for loop comes to the rescue. It is called a for loop. You can think of it as like, do this for 7 iterations, something like that. So here is that same code. We have a little indentation issue here, but basically we start with val says that, and then we're going to repeat howdy 5 times. So here is what our for loop looks like. We're going to go into the syntax of that in just a minute. But see that we have just one howdy instead of 5 howdies, and then we print how are y'all doing. So in this way, we are able to have the computer do the repetition instead of us doing the repetition. Let's move on to syntax. What does this actually mean? This is the theoretical idea of what for loop syntax means. So first you have the keyword for. It being a keyword means you can never have a variable of that name. There's a couple other restrictions too, but for is the word that allows us to initialize a for loop. Inside here, this is the initialization. Here we create some sort of variable. In the test, we test that variable to see whether we're done yet. This is how it is this test area that we're able to show or tell it how many times it needs to execute. And then this update step is some modification to the variable we initialized here. Then we have these curly brackets, which is going to be the body of the for loop. These are the statements that we want to be repeated. So here is how it works. It is going to perform that initialization once. It's going to create that variable one time. Then it's going to start repeating the following. So check if the test is true. So this is basically like we're going to initialize a thing. If the test is true, run the statements. If it's not true, stop. Then we're going to perform the update. We're going to make some change to this initialization value. And then we go back here and we're going to check if the test is true. And if it is, we execute the statements, we perform the update. We're going to check the test again. If it's not true, we're going to stop. So this is some shorthand for that repetition. Remember, we create a variable, we test it, we run the statements, we update the variable. We test it, we run the statements, we update the variable. We test it, we run the statements, we update the variable again and again until the test fails. So until the test returns false instead of true. And then we stop looping. Let's look at a more concrete example. So here this is what we saw before, where we're repeating howdy 5 times. So we have int I equals 1. This is the variable that we're creating. Generally, for loops, it is okay to have single letter variable names. This is one of the only places where that's an acceptable practice. And generally in a for loop, that variable is called I. So int I for index, equals 1. So we've created this variable. Now we are going to move to the second piece of the for loop. We're going to move on. Oh, I guess I can explain this a little bit more. This is going to tell the compiler what variable should be used in the loop. It's going to be, as we mentioned before, it's going to be performed once. This is called a counter variable or a loop control variable, or sometimes it's even just called a loop variable. You can use any name, not just I. I is fairly standard, but sometimes it's helpful to give it a longer variable name to better explain what I means. If you're going to be using the variable a lot, giving it a clearer name is ideal. You can start at any value or the value of another variable. It can be an expression. So long as you have the creation of a variable name, an equal sign, and some value, that's all that is necessary. It doesn't have to be 1. It is often 0 instead of 1, but it could start anywhere. So now we're moving on to the test. So we've created this variable called I. Now we need to tell Java the value that I should be when we stop. So we're saying that we can continue looping until or while I is less than or equal to 5. So while this Boolean expression returns true, so while this is true, while I is less than or equal to 5, we're going to keep going. That's what the test means. So it's testing the loop counter against a limit. You can use any comparison operators here. You can do less than or equal to, all of these things that you are used to. You can use equal to. It's very uncommon in a for loop, as is not equal to. It is generally better to use one of these more flexible and definitive options. So less than or equal to, greater than or equal to. Generally, if you have a bug, this is called an off by 1 error. Often you're expecting it to run 5 times, but it's only running 4 times or something like that. Check what sign you're using. You probably need an equal sign where there wasn't one, or you need to remove an equal sign where there was one. This is a common place where bugs pop up. It is also possible, instead of using these operators, to use anything else that returns a Boolean value. But if you're doing something like that, it is possible that you want to use an indefinite loop instead of a definite loop. If you can't use one of these, it's possible that the for loop is not the right tool for you to be using at this time. And then finally, let's talk about the update. So the update, all this means is we're going to make some modification to the variable we created. So this is our I here. We need to increment it. We're going to perform the update. Generally, this means adding 1. So we're able to use the shorthand I++. But you can do any update that you want to. You could subtract 5, you could multiply by 300, whatever it is that makes sense for you in updating that variable. I was just pausing. My instincts are telling me to ask you if you have any questions, but this is a video and you can't do that. Please feel free to message me if you have any questions. I'm happy to answer them. But let's get into some more examples, because I feel like that is how I learn best. Let's talk about repetition over a range. So if we were to have, we wanted to print each value from 1 to 6 as well as its square. Here we're writing in 1 by hand, 2 by hand. We had to type each of these things individually. We had to make sure that if we were copying and pasting, we had to do it very specifically, making sure that we've made all of the changes necessary. If this was a non-loop solution, what if we had to go all the way up to like 700? This would take forever. It would take 700 lines, and we don't want that at all. So seeing something like this or imagining what this would look like, you can think to yourself, I want to print a line for each number from 1 to 6. And you can turn that into a for loop. The for loop does exactly that. So here we have for int I, we're creating our I, and we say I is less than or equal to 6. So it is going to run the values of I as it loops through. It is going to have the value of 1, the value of 2, the value of 3, the value of 4, and 5, and 6. And once I becomes 7, this will fail and the loop will exit. So I'll show you what that code looks like in a minute. Sometimes I tell you when you're reading code, what the words are that you should say to yourself to help you read code faster. So here you would say for each integer from 1 to 6, print something. That's how you would translate this statement into sort of understandable words. Let's walk through what that looks like. So here is our for loop. We are going to see what the output is. So we start with I equals 1. We're going to do the test. Is I less than or equal to 6? And it is. I is less than or equal to 6. So we're going to go into the loop and we're going to print it out. So we're going to say 1 squared equals 1. Great. Now we're going to update the variable I++. So now our I equals 2. We go back to the test to see is I still less than or equal to 6? And yeah, it is. So we're going to go into the loop and we're going to print that out. Then the same thing is going to happen for 3. Once we update I, 3 is still less than or equal to 6. When we update it again, we get 4. 4 is still less than or equal to 6. We're going to update it. We get 5. 5 is still less than or equal to 6. We get 6, which is less than or equal to 6. And finally, when we do this last update, I is going to equal 7. And when we do this test, it's going to return false. This statement evaluates to false, and so we do not go into the loop. We move to the first statement after the loop body, and then we can print out our celebration there. I want to show you this running in code just so you can see. I'm using a trick here that can be kind of helpful as you're running code. I'm using a scanner just to help me understand what's happening. So I'm going to print out a line, and the program is not going to continue until I hit the enter key. So once I hit the enter key, it'll run again. This just helps me see my program running slower. I can see things at different times. So otherwise, you can see this loop is the same. I starts as 1. I is less than or equal to 6. We increment by 1 each time, and we print I is something and then its value squared. Then I have the next line so that it pauses. So it's only going to give it to me 1 line at a time. So here we have I is 1, squared equals 1. I'm going to hit the enter key, which means we're going to move on to the next iteration. I is 2, I is 3. We're still looping here. I is 4, I is 5, is 6, and then we exit the loop and we celebrate with a whoop. I want to talk about one additional thing here. When you create this value int I equals 1, the variable I is only going to exist inside this block of code. Once this close curly bracket occurs, you can't use the variable I again. So if I try, you can see I'm getting an error here because I cannot be resolved to a variable. It doesn't exist. The compiler can't figure out what I is, so it doesn't know how to print it because I only exists in there. If I move it into the loop, you can see it has no problem. But if I move it out of the loop again, you can see that now it doesn't work. So keep in mind that when you create that variable, you can't use it outside of the loop. I am just going to format that again. Got a little extra tabs in there. Okay, now let's go back and see a different type of loop. So in this loop, we are printing like a square type shape. So we print some symbols, the plus sign to indicate a corner, and then some dashes to indicate a straight line, and another corner over here. And then we have a loop. We start I equals 1, and we want to go until I uh, is less than or equal to 3. We increment by 1 each time. It's a pretty standard for loop. It's going to execute 3 times. Inside that, we're going to print 2 different lines. The first one is going to print a wiggly line that goes in, and then this one is going to be a wiggly line that goes out. Notice that you have to use 2 slashes here in order to have it print 1 slash. This is the same slash you would use for a new line character, a tab character. So that's called an escape. An escape character is like /n or /t for tab. But because this character is used to escape things, you have to escape. It has to escape itself in order to print that character. So here we're adding 2 slashes, but it's only going to print 1 of those. If we only included 1, there would be an error because it thinks it should be escaping something and it can't escape a space. So it's going to print 1 of these characters and 1 of those characters. We're going to do these lines 3 times, and then we're going to end up with we're going to end with another line at the bottom. So it's going to do something like this. It's going to print out the wiggly lines. Let me show you that in code. I called it the wiggle box. So I want to show you what I was talking about. If there was just 1 of those slashes, it says an invalid escape sequence. There's only certain things that you can escape. I'm not sure if your resolution will allow you to see that, but you can only do /b/t/n/f/r/double quote /single quote or // not /space, which is what it is right now. So if I add that back, my error goes away. And I'm going to run it, and we should get a sort of wiggle square, a wiggle box like this. If I wanted, instead of 3, if I only wanted it to be 2, I can run that and it's going to be a smaller wiggle box. If I wanted it to be like really big, I could do that too. And we have a really, can I even get to the top of that? Yeah. A really big wiggly box. So that's really helpful. We can just change the limits and automatically make something bigger or smaller than it was before. Instead of having to copy and paste a whole bunch of things, it gives us a lot of flexibility. So getting it back to what it looked like. Great. Okay. The next thing is a question for you. If we were in class, we would do this as a poll. But for right now, just come up with an answer. Pause this video, come up with an answer, and see what you think. How many asterisks are going to be output by the code? If you paused it, I think you're back now because you're hearing me say this. So let's think about it. I don't know what happened. Bring me my slide back. Okay, so we're starting at I equals -2. We are going until I is less than or equal to 13, and we increase by 1 each time. So we see we have -2, -1, 0, and then 13. So we need to execute this, whatever it is going to be executed 16 times. And then inside here, we are going to print 3 asterisks each time within the loop. So ideally, it's going to be 3 times 16, which I think is D48. But naturally, we are going to let Java run it for us. So I'm adding a counter here just so that I can keep track of how many asterisks there are. Otherwise, the code is exactly the same as what you saw before. Inside this for loop, we know that we're adding 3 asterisks. So I'm going to say, oh, it should be num asterisks plus equals 3. And this means that it's going to just keep track of how many asterisks there are, and I can print it again here at the end of the program. So we're going to print a bunch of asterisks, and you can see that so long as we add 3, which is the number of asterisks we added, we get to the number 48. So we were right in saying that it was D. Okay, finally, let's talk about, this is another program called the rocket ship. And what it's going to do is it's going to say T minus some amount. You're going to count down. Here we have int I equals 10. We're starting with 10. We want I to be greater than, we haven't done a greater than, we've always done less than before. So we're going to say it's greater than or equal to 1. And we're going to decrement the value by 1 instead of incrementing it. So the value is going to decrease by 1 each time. It starts at 10, and then it's going to get the value 9, and then 8, and so on. Within that, we're going to print the I that we have, followed by a comma and a space. We're going to do that 10 times. And at the end, we get to blast off, and we say the end. So I'm going to run this for you. You can see T minus all of the numbers, followed by commas, and then we have a successful launch. So that is the end of this brief explanation of for loops. We're going to talk about some issues with for loops in the next section. So please stay tuned for that. But it might be time for you to take a little break. So feel free to go get some water, do something. I'll be here when you get back. See ya.